In lesson 89, we'll be looking at the average value of a function, and then we'll go ahead and discuss the mean value theorem for integrals. So let's start with the average value of a function. So we have two graphs right here. The areas are supposed to be the same. A to B are the same. So the first tank here, or these are supposed to represent tanks of water, and you see a cross section here. So same tank, first one, the water's completely still. The second one, the water's been disturbed. But your area under the curve is going to be the same. Well, just thinking through this, we know that area of this rectangle is going to go ahead and equal base times height. Well, over here, realize that the area under the curve is going to equal the average, well, we should say the base, still the base, times the average height. And so we can use this to help us find what the average height of a function will be. Notice that this one here kind of represents a sine graph, and we could find the average height, or we can use that to help us find the area of the curve. Well, we know that area, so here's base times the average height, but area under a curve is actually equal to the definite integral from a to b of the function. So we're referring to this one over here. So what we can do here is we can just multiply both sides by 1 over b minus a. And if we do that, it will give us this, because these will cancel. We'll have our average height equals 1 over b minus a times the integral of the function. So this is a helpful idea or principle that can help us find the average height of a function. So a horizontal line, the height would be the same all the time. Any other function, that the height is changing, but we can find the average height over a specified interval. So here it is written again, and they'll say the average value of a function, because height really is negative, and we could get negative answers for average value, is 1 over b minus a, where b and a are the endpoints of the interval, and the integral of from a to b of f of x dx, the function that we're talking about. And notice f must be continuous. It won't work if it's not a continuous function. So let's take a look at this. Find the average value of the function f of x equals x cubed minus 10 on the interval -1 to 2. Well, that average value is going to equal 1 over b minus a times the integral from a to b of the function that we are referring to. So 1 over 2 minus -1 is going to be equal to, or not equal to, times the integral from -1 to 2 of the function we're referring to, so x cubed minus 10 dx. And so we get 1/3, and then this integral is going to be 1/4 x to the 4th minus 10x, evaluated from -1 to 2. So we have a 1/3 out here. Putting in 2 will give us 1/4. 2 to the 4th is going to be 16 minus 10 times 2. Oops, we don't want to end that yet. And then minus when we put in -1. So 1/4, -1 to the 4th is just 1. Minus, put in -1. 10 times -1 is going to be plus 10 here. And then simplifying this, scroll up a little bit, we have 1/3. This is going to be 4. 4 minus 20 is negative 16. And then minus 10 plus a fourth over here. So we have 10 and 1/4. But it ends up that we're subtracting those. So we have 1/3 times negative 26 and 1/4. So we have 1/3 times 4 times 26, 1/4. So we have negative 105 fourths. 3 goes into this 35 times, so we have negative 35 fourths, which is equal to negative 8 and 3/4. So that would be the average value of the function. Looking at the next one, we just have the definition of the average value of a function again. So we want to approximate this one. So we have our function is f of x equals 4e to the 2x on the interval 0 to 3. So our average value is going to equal 1 over 3 minus 0 times the integral from 0 to 3 of 4e to the 2x dx. And so this is going to be 1/3, and we're going to find the integral of this here. So let's do a little guess and check here. We're probably getting better and better at this. So we might guess, oh, e to the x, well, it's itself. So we're going to guess that it's 4 times e to the 2x. But this 2x is going to cause a little bit of a problem. So let's go ahead and think we'll probably have to multiply this by 1/2. So here's our guess. Our guess is 2e to the 2x. Let's check it. So check by taking the derivative. Derivative is going to be, let's put it in red so we don't get mixed up here. So this is our check. This is 2e to the 2x. Using the chain rule, we want to take times the derivative of 2x, which is 2, which gives us 4 times e to the 2x, and that is what we wanted. So down here, we can plug in that the integral is 2e to the 2x, evaluated from 0 to 3, and we could plug in and find those values. Now, actually, it does say approximate, so really, we could just put this in our calculators. So actually, I'm going to go back to this one right here, and we're going to do 1/3 times the integral. So math, 9 of 2 times e to the, oh, I'm sorry, putting the wrong thing in there. Getting ahead of myself. So we went from 0 to 3. Now we want the function 4 times e to the 2x dx. And we get that the average value is 268.29. So there we have the average value. All right. Moving on to the mean value theorem for integrals. If f is continuous, so it doesn't work if it's not continuous, on a closed interval a to b, there exists at least one number c between a and b, so in that interval, so that the function at c equals, we just looked at this. This is the average value. Okay, so that's the mean value theorem. F has to be continuous on the interval. There has to be one value c within that interval. So if you plug c into that function, it will give you the average. It's kind of like, I'm going to scroll all the way up to the beginning. In our interval right here, I'm going to make this a little bolder. In our interval, they're blue, on this blue function. Here's the average. That means somewhere, shouldn't have done that. That means somewhere on this graph, at least once, it had to hit that average. So in this case, it looks like it probably would have hit the average 4 times. But the mean value theorem says it has to just hit it at least once. So given that the average value of f of x equals 2x cubed on the interval 0 to 3 is 27 halves. So they actually told that to us. We could have found the average value using what we just mentioned, that it's 1 over b minus a times the integral from a to b of the function. We could have found it. They told it to us in this case, so 27 halves. Use the mean value theorem for integrals to find some number c such that f of c equals 27 halves. Well, let's take our function. So it's saying this function somewhere has to equal 27 halves. So let's find that value. So we will multiply both sides by 1/2. And we get x cubed equals 27 fourths. We'll take the cubed root of both sides. Well, the cubed root of 27 is 3. Cubed root of 4. We don't really have a specific value for that. So we can just leave it like that. We could try to simplify and multiply top and bottom by the cubed root of 2, because that would, multiplying by the cubed root of 2 down here would give us the cubed root of 8, which is 2. So there's an answer. There's an answer with no radical in the denominator. In fact, we could have, if we wanted to, just taken the cubed root here, and we could have another way of writing it as it's just the cubed root of 27 fourths. So that is the mean value theorem for integrals.